Alright, this is chapter 12, section 1. So in chapters 12 and 13 we do something completely different than we've been doing in the previous chapters, 9, 10, and 11. 9, 10, and 11 dealt with derivatives. Chapters 12 and 13 go backwards, basically, where you're integrating. And what you're doing with integration is you're taking the derivative, and they start with the derivative and ask you to find the original function itself. And that's called integration. So we'll be talking about the indefinite integrals in this section. Next section, the power rule, then integrals involving exponents and logarithms, and then applications of business and economic problems. So first we talk about the indefinite integral. We've studied procedures for and applications of finding derivatives of given functions. We did that in the last 3 chapters. We now turn our attention to reversing this process of differentiation. When we know the derivative of a function, the process of finding the function itself is called anti-differentiation. For example, if the derivative of a function is 2x, we know that the function could be x squared, because the derivative of x squared is 2x. But the function could also be x squared plus 4, because the derivative of x squared plus 4 is also 2x. Thus, any function of the form x squared plus c, where c is some arbitrary constant, will have their derivative equal to 2x as its derivative. Thus we say that the general antiderivative of f prime of x equals 2x is f of x equals 2x squared plus c, where c is a constant. The process of finding an antiderivative is also called integration. The function that results when integration takes place is called the indefinite integral, or more simply put, the integral. We denote the indefinite integral, that is the antiderivative, of a function by this here. This is the integral sign. To indicate the general antiderivative of the function f of x equals 2x. The expression is read as the integral of 2x with respect to x. That's how you read that. The integral of 2x with respect to x. In this case, 2x is called the integrand, and the integral sign, right there, indicates the process of integration. And the dx indicates that that integral is to be taken with respect to x, when you see the dx there. Because the antiderivative of 2x is x squared plus c, we can write integral 2x dx equals x squared plus c. Now here's a couple of formulas. When you're taking the integral of some variable to a power, you just add 1 to the exponent and divide by that same number. Then you add plus c. Now this is not true if you start out with x to the negative 1. That's a different case, and we'll cover that in future sections. But for now, you just take the exponent, add 1, and divide by that new exponent. The integral of 1 is just x. A constant times a function is just a constant times the integral of the function. And the integral of 2 functions being added or subtracted is the integral of each one added or subtracted. Alright, so we start out with 3x squared. What is the integral or the antiderivative? Well, you add 1 to the exponent, so you get 2 plus 1, and you divide by that 2 plus 1. And so 2 plus 1 is 3. 3 divided by 3 is just 1, so you just get x cubed. So f is x cubed plus c, or you can say the integral of 3x squared dx equals x cubed plus c. And what about x cubed? Well, you add 1 to the exponent and divide by that same number, and you get 1/4 x to the 4th. So the integral of x to the 3rd dx is 1/4 x to the 4th plus c. What about x to the minus 1/2? Well, same idea. Add 1 to the exponent and divide by that new exponent, and you get 1/2, and when you divide by 1/2, you flip it and multiply it times the top, and it's really just multiplying by 2 over 1. And so you get 2 x to the 1/2. Now here's a whole family of graphs of 2x to the 1/2 where c is different. where c is 0 is this one right here, where c is 3, c is 5, negative 2, negative 5. So you can see the same shape, it just shifts it up or down depending on what c is. Alright, what's the integral of the cube root of x dx? Well, the cube root is 1/3 power, so you take the 1/3 and add 1 and divide by that new exponent. And that's 4/3 divided by 4/3, so when you flip the bottom and multiply, you get 3/4. And 4/3 is 4th power and 3rd root, so 3rd root of x to the 4th. 1/x squared is x to the negative 2, so you add 1 and use that new exponent, so you get negative 1 and negative 1 there. And so you get a negative, and x to the negative 1 is 1/x. Example 5a, the integral of 4. Well, the integral of just 4 is, you can bring the 4 out front, and the integral of dx is just x, so you get 4x. The integral of 8x to the 5th is 8x to the 6 over 6 plus c, which is 4/3 x to the 6 plus c. And the integral of each one of these is x to the 4th over 4 plus some constant d plus 4x to the 2nd over 2 plus some constant e. And this becomes 1/4 x to the 4th. This becomes 2x to the 2nd. And you can combine these two constants to just label it a new constant of c. When you're talking about constants and you've got different constants for different integrals, we tend to use capital letters. And we usually start with c, then we can go d, e, f, g, or as high as you want. Number 6, the integral of x squared minus 4 squared dx, well, you multiply that out, and now you just take the integral of each one of those. You get x to the 5 over 5, you get 8x to the 3rd over 3, you get 16x plus some constant. And when you clean it up, it looks like this. The integral of this polynomial is 4x to the 4th over 4, 2x to the 2nd over 2, plus c, and when you clean it up, it looks like that. And this one is 2x to the 4 over 4, x to the minus 1/2 plus 1 over minus 1/2 plus 1. It's x to the negative 5 plus 1 over negative 5 plus 1. Well, 2 over 4 is 1/2. And that's 1/2 power, and 1/2 power, when you flip the bottom 1/2, it becomes 2 up top. And this one is, that's negative 4 and that's negative 4, so they cancel, making it positive, and that's x to the negative 4. Number 7, they give you the derivative and ask you to find the original function, so you're going to integrate. So you take the integral of 300 minus 0.2x. So you get 300x, you get 0.2x squared over 2 plus c. And so when you simplify that down, you get 0.1x squared plus c with the 300x in front. Now, it's nice to sometimes be given a situation where you can nail down what your constant is. Well, we know that when you sell 0 items, you make 0 revenue. So we know when x is 0, r of 0 equals 0. So you plug in 0 into the function, and that can help you to nail down what c is. Well, if this is 0, that's 0, and that's 0, c has to equal 0. So this is your general function. This is your specific function for the revenue. And then you plug in 1,000 and you get the amount of revenue that's produced for 1,000 motherboards that the company is producing. So here's your derivative and here's your original function. So let's look at similar questions from the textbook that are similar to your WebAssign question. If f prime is 4x cubed, what's the integral of 4x cubed? Or what is f? So you add 1 to the exponent and divide by that number and plus c. And same thing here, you add 1 to the 7 and divide by that new number, so x to the 8th over 8. 8x to the 4th over 4. Now you might say 3x to the 4 over 4, but this is a constant. This is just 27. And derivative of a constant is just, or the integral of a constant is just that number times x. And so this one is 14, x to the 14 over 14. And it's all plus c. The integral of 3 is just 3x. The integral of x to the 3 halves is 5 halves divided by 5. And when you flip the bottom, it becomes 2/3 up top. This one's x to the 5th over 5, 9x to the 3 over 3, and 3x. and when you clean it up you get this guy here. 17, the integral of 2 is 2x. The integral of 2x, square root of x is, remember, that's 2x to the 1/2. So you add 1 to the 1/2, you get 3/2, and divide by 3/2. And so you really get 4/3. And you can write it this way with the radical, or you can write it this way with the exponential, exponent being a fraction. Just depends on what the what WebAssign asks you to write it as. They might ask you to write it without fractional exponents. Just look at what they give you and ask you to do, and do it that way. 5x, 5 over x to the 4th, that's 5x to the negative 4, so your integral is 5x to the negative 4 plus 1 over negative 4 plus 1, which is really negative 3. And so you got negative 5/3, but your x to the negative 3 crosses the fraction bar and is in the denominator there. This one, when you integrate x cubed, you get x to the 4th over 4. Integrate the 4, you just get 4x. And that's 5x to the negative 6, so you add 1 to negative 6, you get negative 5, and you divide by that negative 5. And you clean it up and you get this guy here. 29, I multiplied this guy out, this guy times itself. Then I multiplied it times the x cubed, and I got this. Now you can integrate each individual term. And you get what you get here. Nothing unusual there. 31. This one, if you break it up into two separate fractions, you get x over x cubed, which is really 1 over x squared. And 1 over x squared is x to the negative 2. Then here you get 1 over x cubed, which is really x to the negative 3. And now when you integrate both those, you add 1 to the exponent and divide by that new exponent. And you simplify it, you get here. The integral of this equals 2x to the 9th minus 7x cubed plus c. They ask you to find the original, to find the derivative. So you just take the derivative of that guy. You get 18x to the 2nd. You get 35x to the 4th. And this one, they give you this guy here. And so when you take the derivative, you get 5 minus 1/2 x. And so your original function was 5 minus, or your original function is this guy, and your derivative is this one. Alright, so they give you the derivative of revenue, and you integrate that, and you get this guy here. Okay, and that's your revenue function. 43, they give you the derivative, which is marginal revenue, and you integrate it, and you get your revenue. And then they ask you to find out what's the revenue when you produce 500 items. It's $22,125. 45, they give you the derivative, and you integrate it, and you get this guy here. And then you want to figure out what C is, and you know that if you have 0 items, there's 0 action potentials when t equals 0. So when you plug in 0, you get 0. So you plug in 0 here, and with all these guys zeroing out equaling 0, C has to equal 0. So you can change this guy to this very specific function. You know what C is, it's 0. And 49, they give you this guy here, and they ask you to integrate it. So you get 1/4 x, you get minus 100x to the negative 1 divided by negative 1, plus some number c. And when you clean it up, it looks like this. And now if you plug in, they tell you that when you plug in 20, you get 400. So C bar of 20 equals this, equals 400. And with that, you can figure out what C is, because this is 5, and that's C, and that's 400. So 10 plus C equals 400, so C has to be 390. So now you know the specific C bar function. And now you just plug in 100, and you see that you get a average cost per unit of $416 per unit when the 101st unit is being produced.